Okay, 3.372. We did this one in class several times. It says you're supposed to find the quadratic equation in this form that has a vertex of 1, 4 and goes through the point -1, -8. Did I make sure you get that right? Yes. And I showed you several ways to do it. I'll do the simplest one from the class, and that is, okay, if I know the vertex, I know this form in which we have a parentheses x minus b squared plus c, where b and c are the coordinates of the vertex. So I would have f of x equals a x minus 1 squared plus 4. That's the coordinates of the vertex. But then I have to find a. Well, this equation is supposed to go through the point -1, so if I put in -1, I'm supposed to get -8 for the y value. So -8 is supposed to be a times x, which is -1 temporarily, -1 squared plus 4. So -1 subtract 1 is -2, squared is 4. So I get 4a plus 4 equals -8. Subtract 4 from both sides and divide by 4. So now I can finish this equation back here because I now know what a is. It's -3. So I have this equation, f of x equals -3 times x minus 1 squared plus 4. Now I should be able to put in 1 and get 4. And I should be able to put in -1 and get -8. Now what I need to do is change it to this form. And that's just multiplying this out. So x minus 1 squared is going to be x squared minus 2x plus 1. That's what this squared is, and that's all times of 3, and I got to do the square before I multiply. And so now if I multiply the -3 in, I get -3x squared plus 6x minus 3 plus 4 is plus 1. And there's the answer they were looking for. Now 76 says we have f of x is this, g of x is this. It says graph them. So this is a parabola, a normal one that's flipped upside down and up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I move over 1, it's 1. Over 2, it's down 4. So it looks something like this. If this is 9 and this is 1, and if that's 1 over and that's 2 over and this is past that. Then if I draw y equals 2x plus 1, if I put in 0, I get 1. If I put in 1, I get 3. If I put in 2, I get 2, 4, 5, which happens to be that point on the graph, the other graph. And it would go like this. Now it says solve for when the y value of f equals the y value g. Find the x's where the y value of f and g are the same. So I set it equal. This is how I get the y value, -x squared plus 9. This is how I get the g, which is y value, so 2x plus 1. And if I can figure out for what value is x the same. I just like -x squared, so I'm going to add x squared to this side and subtract 9 to get 0 on this side. So I'll have plus x squared plus the 2x, and I'll subtract 9 from 1, and that'll be -8. And I can use the quadratic formula, but I think that'll factor to x, and what times what makes negative 8, and has a difference of 2. Well, I think 4 and 2. And if I want a plus 2 and I need to subtract, one of these has got to be negative. So I think I'm going to go plus 4x minus 2x. So I get x squared minus 2x plus 4x is plus 2x minus 8. So if I solve this, I get x plus 4 equals 0 and x equals negative 4. I get x minus 2 equals 0 and x equals 2. But that's only if that's equal to 0. So the solution to f of x equal to gx happens when x is negative 4 or 2. It says find the intersection points. Well, if I put 2 into this one, I get 4 minus 4 from 9 is 5, so I get the point 2, 5. And if I put in negative 4, or let's just check it here, put 2 over here and I get 2 times 2 is 4 plus 1 is 5, same thing. Now let's do minus 4. If I put in minus 4, I get 16, minus 16 plus 9 is minus 7. Let's try it over here. 2 times negative 4 is negative 8 plus 1 minus 7. So there's my intersection points. And then finally I'm supposed to shade where f of x, that's the parabola, is greater than g of x. Well, that happens, it's greater. This is kind of the enclosed area where f of x is greater than g of x. It's really these y heights are greater than these, and it says shade a region, but really that's not correct, but I'll go with what they said. That's what they wanted you to shade. Over here, g is greater than f. Over here, g is greater than f, but in here, f is greater than g. Okay, 780 says we have these x-intercepts, and we're supposed to find parabolas when a is equal to 1, and then again when a equals 2, and again when a equals minus 2, and again when a equals 5. Well, this is way simpler than it sounds. If this is going to be a parabola that has that x-intercept, that means x plus 5 had to be a factor. And if 3 is going to be an intercept, x minus 3 had to be a factor. And so there's the parabola. But this has an a of 1, because this is going to be 1x squared. If I multiplied it out, I'd get x squared minus 3 plus 5 is plus 2x and minus 15. Now if I wanted it to have an a of 2, I would just multiply by 2. And then I would get this, when I multiplied those out, I would get this, and then times 2, I'd get 2x squared plus 4x minus 30. And there's the parabola with a equal to 2. And if I wanted minus 2, I'd put a minus 2 in there, and I'd get minus 2x squared minus 4x plus 30. And if I wanted it with a 5, I'd put a 5 there. So I'd do 5 times x plus 5 times x minus 3. This multiplies out to be this, and I'd take that times 5, and I would get 5x squared plus 10x minus 15. All three of these, if you were to four of these, if you graphed any one of these, it would go through the x-intercept negative 5, 0, and the x-intercept 3, 0. The first two would be right side up, and the last one would be right side up, and the middle one would, the third one here would be upside down. Let's write that in here. Negative 2 times x plus 5 and x minus 3. So there's all the answers and how they work. Okay.